So today we're going to talk about turning feature recognition. And in fact, turning feature recognition is not entirely new. We've demonstrated this in milestone 78 as well. But one of the questions I got after our demonstration, this was a demonstration using our knowledge-based programming, very automated. A lot of people ask me, is it really this easy? Of course, the answer is yes, it's really this easy. But we wanted to show this again from the perspective of somebody maybe programming parts a bit more manually as opposed to using the knowledge base and with so much automation. So we're also going to talk about tool change indexed axes. So this is a new optional parameter for the standard link configuration. And this is intended for machines where the tool change sequence is in fact a macro that performs the indexing of the axis to the specified rotary solution. So I'll talk a bit more in detail about this as we go along with this example. Okay, we're going to start with a pretty simple turning part here. So let's go ahead and start the turning feature recognition. Remember, the input here can be any number of faces, it can be geometry, or the entire solid itself. So I'm going to specify a turning axis. Again, this can be faces, it can be an edge, geometry, or an axis. So I can kind of preview what's created here. And what I want to demonstrate here is, let's say in this example, we're going to drill this inside hole. So I don't have any need to create ID operations. So let's select this, and we can see the result here is that I have an OD contour, a back OD contour, I'm sorry, a front OD contour, a back OD contour, a back face, and a front face groove. Okay, so this isn't quite what I want to end up with yet. So I can see, based on my front OD contour and how my part is oriented in the machine, I'm going to need to change where this location is. So we're going to expand this machining box zone, and I'm going to change where the OD end location is. So if I go and I preview these, I can see that my front OD contour now only extends to this large face, and my back OD contour takes care of this large face. And then you can see here that I probably don't want my machining passes in an OD type of work. So let's also change this area so that it's entirely on the face. So here I'm going to change my back OD start location. So now my front OD contour is here, and my back OD contour is only along here. My back face is along here. Now you can see we've recognized a front face groove. Notice that this doesn't necessarily lie on the front face. This just corresponds to the primary direction of that groove. So now why isn't this area recognized as a groove? So we can change this groove relief angle. So we can see that this angle is less than the 60 degrees that I've specified here. So let's change this to 45 degrees. And now we have an additional groove recognized. So here we see we have a front OD groove. And again, the front OD corresponds to the primary direction of that groove. Okay, so we have a bit of a problem here. One thing the system did not recognize is a front face. Now this is kind of interesting because the part itself doesn't really have a face that I can work with. And I want to show you two ways that you can do this. One is one that you're, of course, familiar with, and that would be kind of creating a manual chain. Or I can do an auto chain on a segment that I created. So, sorry, let's create a chain here. And what I want to show is kind of two ways that we can continue to do this. So if I was to create an auto chain here, and we still allow creating turning operations, of course, on auto chain. So let's go ahead and create a facing operation on this chain feature. Let's say this is my facing operation. I'm going to do a default all, okay? So let's name this my facing operation. I'm going to select the roughing tool, and let's just put in some feeds and speeds here just for simulation. And let's press OK. Okay, so I have an error here. Feature width must be greater than 0. So this is something that's really frustrating for a new user who may be using something like an auto chain. They don't necessarily understand what this parameter means. Now you guys all, of course, are expert users, so you know that we can go to the Strategy tab. We'll change this type of work to face, and then I can press OK, and my passes are created as I expect. So that's one way. Another way is we can create turning features on that segment. So let's specify a turning axis. And here I'm going to specify the type of work up front. So let's create a face contour. Now we have our front face contour. We'll do a roughing operation. And now we can see on the Strategy tab that that type of work is not available. So I'll create the facing operation. And so it's much easier for the user to understand how that type of work is defined. So we have a facing operation. Let's do an OD roughing operation. I'm keeping most of the same parameters here. I'm just going to rename it. So again, I didn't have to change type of work. It's the same process. I just created an OD roughing operation with the exact same tool. So let's do the OD groove. So I can do this groove here. Let's do a grooving operation. And again, I'm going to do a default all. Let's call this OD groove. We'll select my grooving tool. And again, just put in some feeds and speeds here. Okay, so I've got my grooving operation. I'm going to need to specify finish feeds and speeds as well. Sorry. Okay, and then we'll also specify a front face groove. And here I kind of want to show the benefit of having this live preview here. So this machine has an indexing head. So we're going to specify the angle that we want this at. But it's really nice to be able to preview what my angle is so I can verify that the orientation is correct when I'm creating the operation. So this is my face groove. Okay, and then we'll program a drilling operation. So let's just select the whole part. We'll recognize the holes based off this largest diameter. And we get one hole, and my engineer who's designed this part has it at 23.5 millimeters in diameter. And of course I only have a 22 millimeter drill available. So this is an insert drill modeled off of a boring bar in ESPRIT. So let's create a drilling operation. And I'm going to default all here so you can just see what I'm doing. And we'll select that insert drill, program some feeds and speeds. And just to recap what we've shown again, we're going to specify a through depth. And we're going to use our radial offset parameters to be able to machine this entire hole, even though we only have this 22 millimeter drill. So let's do an initial offset of 0.75 millimeters, and we'll do an incremental offset of 0.75 millimeters. Let's specify some feeds and speeds. And we'll press OK. So now we have our drilling operation. So let's go, let's program a pickup operation. So again, just to explain what we're doing here, so we'll just name this a pickup operation, and I'm going to select the subspindle fixture to pick up the part, and then we'll do a release. Then I can use these same processes that I used on the front, so let's use my facing operation, and I'm just going to copy it to the back face, and I'm going to take my OD roughing, and I'm going to copy that to the back OD contour. So we already have our entire part programmed. It really is that easy. So let's go ahead and simulate. Now, just for the sake of time, I'm not going to simulate quite this whole sequence, but let's pause on this last link where we're going back to the tool change position. Okay, so I'm going back to the tool change position, and as I have defined in my machine project file, the tool change is going to occur at minus 90 degrees. So here the link is already over, the tool change sequence starts to happen, we change tools, we have loaded the new tool, and now the new link begins. The link takes care of indexing the tool back to B0, which is the specified rotary axis, and of course we approach the next operation. So let's see what this looks like in the NC code. So here after our tool change, for our grooving tool, we see that the link takes care of indexing to that B0 position. Now let's look at this new tool changed indexed axes parameter. So I'm going to edit the machine, and we have a new parameter in the links tab called tool change index axes. And just so that you know, remember we can always go to this help file to see what these parameters are. So here we have the tool change index axes. This is an optional parameter, but this help documentation can really help specify when you're referencing all of these parameters and what they do. So all I'm going to do is add B to this tool change index axes, and I'm telling the system that the B axis is moved as part of the tool change sequence. So let's press OK. The links will recalculate. Let's start again from this link. So again, we go back to the tool change position. The tool change takes care of indexing to the minus 90 degrees position. We load the new tool. And now, as soon as I've started the next link, the head is already rotated to the B0 position. So in fact, the tool change took care of indexing the B-axis to that machine position. So now once I start the link, we start at B0, and all we do is approach the part. So again, let's post that code and see the difference. And now we can see that there's no B0 in this move to that operation. So again, this is useful for machines where that tool change sequence is a macro or part of the tool change command.